In recent versions of C#, great improvements have been made to how it indexes collections, and you should be taking advantage of that. Hi there, my name is Brendan, and in today's episode of DevChatter, we're going to be taking a look at range indexing and reverse indexing, two features that got added to C# recently that you should be absolutely using in all of your solutions. Let's have a look at what's going on with indexes in the current version of C#. We're here right now with a .NET 6 solution available to us recently. In the changes to how C# uses indexes are reverse indexes and ranges in those indexes. These are two things that were not in C# in the beginning of C# and are much more recent additions to the language that you should be using. Let's go ahead and take a look at how those work. In this setup, as I said, it's a .NET 6 application, and I currently, as you can see down below, have it running with a watch in it. So anytime I change this application, it's automatically going to run it down at the bottom. So we can watch for those changes to happen every time I save. Let's go ahead and take a look at the first change that we can make. In order to get started, we're going to want to create a couple of collections to index. Let's start off with two of those. We'll start off with a letters collection and a numbers collection, just for simplicity and a couple of examples. Obviously now we've updated this and created a letters array, but it doesn't really do much. So what do we need to do with this? Somehow use it. So let's use this one in our reverse indexing. So we talked about reverse indexes, and what they are is essentially indexes, but instead of starting at the beginning of the collection, they go from the end to the beginning. So it gives you an easy way to know what the last item is. The index of the last item in your collection using normal indexing is the length of your array minus 1. Which means that you always have to check the length of your array and subtract 1, and it's kind of a mess. So if we were to do that, we would do this. And when we build this, you'll see that it does print out the letter I. So we did a console write line and did the last item in the collection. And this works fine. This is what we've been doing the whole time up till now. But what we can use instead is reverse indexing. And in C#, what they did was they decided to use the caret operator, which is the little up arrow. And that's the indicator that you're using a reverse index. Some languages use negatives. I think for reasons to do with the specifics of C# language, they decided not to use it for this. So let's go ahead and try it. You'll see that the two of these commands both print out the letter I, and you can obviously see that one is much shorter than the other. Now I'm going to jump out there and talk about one thing that you might be wondering, and that is, well, hang on a second, if we index normally, we start with 0. Why does this one start with 1? Well, I think the reason for this goes to wanting to align with the way that other languages use indexing, reverse indexing specifically. In a lot of other languages, I mentioned that they use negative values instead of using the caret operator that we are using here to do a reversal. And because the other languages use negative, they would have to write -0, which is a little weird. And so in order to avoid that weirdness, they just start with 1 when reversing the index. So it's -1, or in our case, caret 1. And that should work pretty well. What that does mean is that caret followed by the length of your array is actually going to be the first item. Now, you're not normally going to use reverse indexing all the way up to that point like that unless you were doing something in a reverse loop. At this point, we can use reverse indexing, so as you can probably guess, these would be the next values. I'll go and put them in here real quick and you can see how everything works. We just increase the number to go from the right to the left. And you can see now, once I've put these in here, that I did essentially reverse 1, reverse 3, reverse 5, reverse 7, and reverse 9. Remember, there are 9 items in this collection from letters A through I, and the 9th value in reverse is going to be A. And so that's the same thing as the first value, going with forward indexing. And so you can see that's how they work. The next thing that we wanted to talk about was not reverse indexing, but range indexing. And that means we want to get a set of these values. So let's say I wanted to get a collection of the first 3 letters and print those out. What you can see here, I wrote what is called a range index. And essentially the way that these work is you define the values that you want to use. I started off here by showing you one of the ones where you're missing a value. So what this says is get me the range of letters, starting from the beginning, because I didn't provide a value, and going to the third one. Now, I'm going to show you really fast that I can provide the 0 at the beginning and it achieves the same result. You'll notice in the output here, it says ABC is the result. And if I change that to a 0 and save it, it will go ahead and run again, and you'll see that I still have ABC as the result. That becomes optional when I do that. And I'm going to remove it again, we're going to rerun it, so still works the way we expected. If I were to remove the ending value and instead say that I wanted to start at the midpoint, roughly, I can get the last few items in that. So I got FGHI. And so you'll see that I can also leave off the ending point. And this would be the same as if I were putting in the ending value. As you can see, I can place in the 9 and still get FGHI. And it doesn't really matter whether I include it or not. Now, if I want to get everything up until the second to last value, if I want to exclude that I, skipping the I, what I can do is go to 8. But now you'll see, well, I'm typing this because I know the size of my collection, that's fine. But if I didn't know the size of the collection and knew I wanted to get the range leaving off the last item, all I'd have to do is put in the letters.length -1, and that will get me FGH. So the 3 letters at the end without the last one. I get a little bit of control here, but now you're saying, oh geez, letters.length -1, that's terrible. And you're right, it is. So what should I do instead? Reverse indexing. So let's go ahead and try that instead. Now when I run this, you'll see that I get FGH, and I didn't have to deal with the length, I didn't have to deal with any of that stuff, and I'm able to just say, hey, skip that last one. And just using the reverse index gives me that value. If you don't think that's powerful for being able to choose the section of a list you want to be able to get, and this works, obviously I'm using an array, it will work for lists as well. This is just indexing, it's in the index operator. So if you are working with any of the collection types that allow you to do this, you get this type of both range access as well as reverse index access. Obviously I showed you an example of the reverse index at the beginning, but we can do the same thing and have gone from reverse index 5 to number 1, and that will yield a different set of results, so that gets us EFGH, because reverse index 5 and index 5 are not the same value. I can also again leave out values in the beginning, the end, anything like that, and you get a lot of power out of just this concept. So anytime you're trying to get a subset, try these. They'll really help you out. This can also work for getting a substring of a string, for example. There are a lot of possibilities. I hope to see you using this in the future. Have a great one. Thanks for joining us here on DevChatter. If you like this content, subscribe and click the bell icon to be notified when new videos are uploaded. You can also catch me and the rest of the DevChatter community live on the DevChatter Twitch channel. You'll find links to all this below. Thanks for watching, and happy coding.